Good morning all, I am Joita Moitri, and yes, today is finally our episode 5 from Fun to Explore series from Thermal Physics, and it is our last episode not only from Fun to Explore but also from Thermal Physics. So in the last episode 4, last video, we already spoke about the last chapter from Thermal Physics. So what is even there to speak today? I mean, we spoke about all the chapters in the last 4 episodes. So I don't think there is even anything to speak today. Probably we will just chill today, chill. Well, yes, we will chill, but then we will actually explore something fun. And I personally felt while designing the episodes, like today's episode, the topic, I found it like coolest and deepest. I was like, it's so deep. Okay, so today actually we will speak about 2 topics from 2 different chapters that are actually contradictory to each other. So any guesses, any idea? Any idea? Alright, my mom even doesn't have any idea. So let me tell. So the first topic is C, specific heat capacity. Specific heat capacity. We spoke about it in session 3, heat capacity, and also in episode 2 from Fun to Explore. And the next topic is K, conductivity. It was there in session 5, transfer of thermal energy, and episode 4 from Fun to Explore series. So how are these 2 topics even contradictory to each other? They are from 2 different chapters, 2 different topics. How are they related and contradictory? That is what we will explore today. So, what is first of all specific heat capacity? No, I don't want the mathematical definition. Yes, we know now from episode 2 from Fun to Explore that it is a thermal property, and more the specific heat capacity, more amount of heat is needed to change its temperature. So, it's much like thermal inertia. So in other words, we can actually say that specific heat capacity is actually the ability to hold heat. Thermal inertia, so it's the ability to hold heat. Okay, so what is conductivity? Well, just in the very last video, we got to know that more the conductivity, more the rate of heat transfer. So conductivity basically means more heat is given away. So it's the ability to give away heat, because more the conductivity, more the rate of heat transfer, more faster the heat is actually transferred. So it's the ability to give away heat. So you see these 2 are so opposite. Specific heat capacity is the ability to hold heat, and conductivity is the ability to give away heat. Okay, fine, but what is there to explore in this? Well, you'll see that objects or substances that have high specific heat capacity will never have a high conductivity. Objects that have high specific heat capacity will have a low conductivity, and objects that have high conductivity will have less specific heat capacity. Let's look for examples. Water, very high specific heat capacity but very less conductivity. Silver, high conductivity, less specific heat capacity. Metals, very high conductivity, less specific heat capacity. Then, well, it is pretty obvious, because of course if you have the high ability to hold heat, how will you have high ability to give away heat? Like, it's obvious, if you have more specific heat capacity, you will have less conductivity. Fine, we understand that. Well, you will discover there is more interesting explores today. Now, we know, okay, if you have high specific heat capacity, you will have less conductivity. High conductivity, less specific heat capacity. Okay, fine, no problem. But specific heat capacity and conductivity, they will be always constant. So specific heat capacity of a substance is constant, conductivity of a substance is constant. Unless state change does not take place. Which means if state change takes place, specific heat capacity and conductivity of substance will change. And that is why if you can remember, in session 4 I have clearly said that while you are calculating the math using the formulas for heat, make sure that the specific heat capacity you are putting is of the right substance. Specific heat capacity of ice or water or vapor? Which one? You have to be sure. So you see, specific heat capacity of water is 4200 joules per kg per Kelvin. Okay. Now specific heat capacity of ice is 2100 joules per kg per Kelvin. So you see they are different. And now one more interesting thing is there. That is, being ice, as the specific heat capacity is decreased, because from 4200 joule it has decreased to 2100 joule in ice, solid state, conductivity of ice has now increased. Since it has lost some of its ability to hold heat, its ability to give away heat, which is conductivity, has now increased. So ice, it has less specific heat capacity than water, but it has more conductivity than water, which is pretty obvious because ice, they are solids, they will of course have more conductivity. But you see, we just knew these things, but I couldn't even imagine that these small little things, they are just so connected and they just seem so interesting. My goodness, I never realized it. I mean, I never predicted it. Alright, now there is one more interesting thing. That is, we now know that in one single state, specific heat capacity or conductivity, it will be constant. When state changes, it will change, no problem. Now, we meet one state of matter where it will have two specific heat capacity. Whoa, that's weird. I know. So, there is a state of matter where it will have two specific heat capacity in the same state of matter, despite state change is not occurring. Which state of matter is it? It's gas. Yes, gases, every gases, any gas, oxygen, nitrogen, carbon dioxide, chlorine, any gas, they will always have two specific heat capacity. And in fact, this property of gas, that they have two specific heat capacity, is due to a different property of gas. And interestingly, the property due to which gases have two specific heat capacity, we have actually studied this property in detail with Fun to Explore in the very first episode, compressibility. In the very first episode of Fun to Explore, we have talked about compressibility, and yes, we know that gases, they are compressible, and since they have the property of compressibility, they are compressible, that's why gases, they have two specific heat capacity. Well, with that, we are pretty much done with exploring the explores we have already done in the past 4 episodes. We have explored a lot of new interesting things. I just have something to show you so that we can review it a little. That is, does it seem interesting to you? Because I found it super fun and super cool. Okay, so if you look at this chart, it is basically a chart of the list of specific heat capacity of some substances. So, specific heat capacity of water is 4200 joules per kg per Kelvin. Specific heat capacity of ice, 2100 joules per kg per Kelvin. Copper, 390 joules per kg per Kelvin. Iron, 470 joules per kg per Kelvin. And silver, 230 joules per kg per Kelvin. Now, looking at this, you will actually discover or find out that liquids, they have, you see, L stands for liquid. Liquids, they have more specific heat capacity than solids, and solids, they have more heat capacity, more specific heat capacity than metals. Interesting, right? And the opposite occurs for conductivity. Metals, they have more conductivity than solids, and solids, they have more conductivity than liquids. And yes, with that, we are basically done with Thermal Physics Fun to Explore episode 5. And at the end of this video, I actually have something to tell you all. It's not about this thermal physics, it's just normally for all of you. That is, all of you probably know, but still, if you're an unknown, if you don't know me personally, if you're not from my own school, then basically I am a student of grade 8. I'm done with grade 8, I will start grade 9. And I actually started this video making and all this thermal physics, whatever things I'm doing now, with a crazy mindset. I have basically done it when during this quarantine, when my online classes have stopped and I got a vacation for Eid. That time I started doing it. And so now again I have to start my studying. So the way for the last 1 month I was constantly uploading videos very regularly. Maybe from now on I will actually have to take a break. Especially now at this moment I will actually take a break with my educational videos. But I will be consistent with my blog post, with anything related to my blog, writings, contests and everything. That will be as it is. But with my educational contents from YouTube, I have to take a break. And even after the break, I will do the requested videos. Thanks to all of you who have requested me. I am really grateful to you all. So I'll be back with those requested videos. And yes, basically, I don't know. It's just that for the past few days when I was making these videos, I was really, emotionally a little triggered because for the past few days, I'm just listening to so many bad news around me, especially related to COVID-19. And believe me or not, you will think that I'm doing it because I'm bored. Yes, definitely I'm bored, that's why I'm doing it, speaking in front of the camera while no one watching me and just my mom laughing at me. Yes, but I actually feel when I'm speaking in front of the camera, I actually feel that you guys are sitting there right in front of me, you are laughing and you are thinking that this girl is crazy. And that is the fun I feel. So, I don't know, I just pray that everyone will be alright, because I don't know, the way I'm doing fun in front of the camera, I'm laughing, I'm excited. Will I actually be the same, this fun, this excited, if anything happens to any person I know, my friends, my classmates, any of my teachers, our principal, Yang sir, any of my family members, anyone I know, if anything happens, probably I will not be the same person again, standing right here, speaking to all of you. So please stay safe, stay home, stay safe, and try to explore life. And all of you already know about the contest. So I have told you about sharing. I know you are all of you are trying your best to share it. But last request is please participate. Yesterday I saw that there are 150 views on my blog about the writing contest, Explore page 1. So can I not expect at least 50 entries? At least? I mean, is it too much I'm asking for? So please, it's not just, okay, very good, congratulations Joeita, oh, you're doing so great, Jose. I don't want it. I just want all of you to engage yourself and participate. That's it. So stay home, stay safe, stay cool. And yes, thank you so much.